In this video, I am going to apply Laplace transform to solve this initial value problem. So we have y double prime plus y is equal to sine of 2t, and y of 0 is equal to 1, and y prime of 0 is equal to 2. The standard way of solving this type of problems using Laplace transform is to apply Laplace transform to both sides of this equation. So you're going to apply Laplace transform to y double prime plus y is equal to Laplace transform of sine of 2t. And Laplace transform is linear, so it's a linear operator, so we could just break the left hand side into two pieces. Laplace transform of y double prime plus Laplace transform of y, and that is equal to Laplace transform of sine of 2t. Now remember, Laplace transform of y double prime is this. So Laplace transform of y double prime is going to be equal to s squared times y of s minus s times y of 0 minus y prime of 0, which simplifies to s squared times y of s minus s times y of 0, but y of 0 is 1, so it's going to be negative s, then minus y prime of 0. Y prime of 0 is 2, so minus 2. Now let me clarify something here in case if you don't remember or if you haven't seen this notation. Let's say you have a function f of t. Okay, just this is a side example. You have a function f of t and you take the Laplace transform of it. Okay. This is just standard notation. Sometimes for convenience, we also introduce another notation, uppercase. For lowercase f of t, the function, Laplace transform is denoted by f, uppercase f of s. So in this particular case, so we have applied Laplace transform to y of t. Okay, and that we denote by y of s. So this is just a notation thing. And Laplace transform of y double prime is something you probably already know. In case if you don't know, this is just a formula, okay? You can go ahead and look it up. But for double prime, this is what you're going to get. Now, if I plug in these values on the left-hand side of this equation, what do I get? So it's going to be s squared times y of s minus s minus 2, then plus Laplace transform of y, which is going to be just y of s, and then on the right hand side, Laplace transform of sine of 2t is going to be 2 over s squared plus 2 squared. Now I'm going to combine terms here, s squared plus 1 times y of s, and then I'm going to bring this s minus 2 to the right. That's going to give me 2 over s squared plus 4, because 2 squared is 4, then plus s plus 2. Now I just need to do a little bit of algebra. Once I do the algebra, this is what I get. My y of s is equal to. Now what we are going to do, we are going to take this right hand side of this equation and create partial fraction from it. So it's going to be as plus b over s squared plus 1 plus cs plus d over s squared plus 4. Now I can multiply both sides of this equation by s squared plus 1 times s squared plus 4 and simplify it, and this is what I'm going to get. Once I get this, so what I can do, I can compare the coefficients on both sides of this equation. So s cube has a coefficient of 1 on the left and s cube has a coefficient of a plus c on the right. So it must be the case that a plus c is equal to 1. Similarly, s square has 2 on the left, b plus d is the coefficient of s square on the right. So it's going to be b plus d is equal to 2. And 4a plus c is the coefficient of s on the right, and coefficient of s on the left is 4, and constant term on the right is 4b plus d, and constant term on the left is 10. Now, if I solve all of these things, these 4 equations with 4 unknowns, which is pretty easy, you can solve it by using substitution method, okay? Substitution would give you quick answers. Or you could use elimination method too, so it doesn't matter, but it's pretty simple. Once you solve it, you get A is equal to 1, B is equal to 8/3, C is equal to 0, and D is equal to negative 2/3. So my y of s then becomes this. So I'm gonna just plug in the values here. I'm actually gonna go ahead and make one more step. So it's gonna be s plus 8/3, right? So I'm gonna write it as s over s squared plus 1, okay? Then plus 8/3 times 1 over s squared plus 1. Then the next one is going to be c is 0. So this is going to go away, and d is negative 2/3. So it's going to be negative 2/3 times 1 over s squared plus 4. All right. Now, what I'm going to do, I'm going to go ahead and do a little bit of algebra here, right here. S squared plus 4 is actually s squared plus 2 square, right? Now, if I multiply this top, actually I'm going to move this 2 right here. So that's going to give me just 2 here and 1 here, okay? So why did I do that? So that I can apply the inverse Laplace and to bring it to the proper format. So I'm going to apply inverse Laplace to y of s is going to be equal to inverse Laplace of s over s squared plus 1. Remember, Laplace transform is linear, right? Plus 8/3 times inverse Laplace transform of 1 over s squared plus 1 minus 1/3. So 1/3 times inverse Laplace transform of 2 over s squared plus 2 square. Okay, so this is what I wanted to have. That's why I moved these 2 here. So inverse Laplace transform of y of s, uppercase y of s is just y of t, correct? So y of t. And inverse Laplace transform of s over s squared plus 1 is nothing but cosine of t plus 8/3, this 8/3 times inverse Laplace transform of 1 over s squared plus 1 or 1 square is nothing but sine of t. Sine of t minus 1/3 times inverse Laplace transform of 2 over s square over 2 square is nothing but sine of 2t. Now we just found the solution to this differential equation. Now kind of let me summarize it a little bit. You just apply the process of applying Laplace transform is this. You just apply the Laplace transform to the initial given differential equation, which is this in our case, and then you simplify it, okay? Just use the linearity property of Laplace transform to simplify it, and then you will get an expression like this, okay? Then you use the partial fraction, okay? Partial fraction concept to break it down into pieces, okay, like this, all right? Once you do this, you find the constants a, b, c, and d, and then you put those back into the equation, which is essentially this equation. Then you apply the Laplace transform. inverse Laplace transform, okay? Not Laplace transform, inverse Laplace transform to extract the original format. So if I were to summarize it, apply Laplace transform, do the algebra and partial fractions in the next step, and then apply inverse Laplace transform to get the original solution, okay? That's how you'd solve a differential equation with initial condition using Laplace transform. And this, by the way, is your solution to the given differential equation with initial values. I hope that this discussion was helpful. Thank you very much.